Hello friends, welcome in a lecture of fluid mechanics subject. Myself Mitesh Patel. I am an assistant professor in the mechanical department at a Dr. Subhash Technical Campus, Junagadh. Today's our lecture topic is a pipes in series and parallel connection. So in this lecture we discuss about when the pipe in series and parallel, what the discharge through this pipe and how to find out the discharge when the pipe in series or parallel, and also discussion about the compound pipes which having similarities of series and parallel pipes. Okay, so let's start the lecture. First we look out the pipes in series. Okay, and then we discuss about the compound pipes. First, as shown in figure, the pipe in series. We can say that the three section or pipe, or we can say that the three pipes are connected in series. First one, second one, and third one. These all three pipe are connected in series. Now D1, D2 and D3, you know that the diameter of pipe 1, 2 and 3. Okay, and L1, L2, L3 is a length of pipe 1, 2 and 3. Velocity of flow in pipe 1, pipe 2 and pipe 3 is a V1, V2, V3. Okay. Now F1, F2 and F3 is the coefficient of friction for a pipe 1, pipe 2 and pipe 3. Okay. Now capital is the difference of water level in the two tank as shown in figure. The H is the difference of water level heads is a capital H, and we can say that the capital H is mentioned the loss of head due to the flow is flowing from this tank to other tank. So capital H is defined the total loss of head when the flow is flowing through the this three pipe in series. Okay, now we know that the discharge is a constant in all three pipes when in connected in series. So according to continuity equation, discharge is equal to, for a pipe 1, A1 and V1. A1 is the area of pipe 1 and V1 is the velocity of flow in a pipe 1. Similarly, for a pipe 2, A2 V2, area and velocity of pipe 2. Now A3 V3 is the area and velocity of pipe 3. So discharge is a constant in all three pipes. Okay, according to continuity equation, we know that. Now the difference in a liquid surface level, it's denoted by capital H, we know that, is equal to the sum of the various head losses in the pipe. Okay, so as per the comparison, we write the liquid surface difference is defined by the capital H. So write the capital H. Now sum of the all individual losses when the flow is flowing through the pipe. So first one is the inlet loss, then friction loss in a pipe 1, HF1. HE is the C is the contraction, sudden contraction loss, HC. Now HF2 is a friction loss in pipe 2. HE is a sudden enlargement losses. HF3 is a head loss due to the friction in pipe 3. And now and last, the opening of pipe. Okay, V square upon 2G. Okay, this all are losses sum is equal to the total head loss or total head difference between the two water level surface or water surface of water surface level of 2 tank, okay, as shown in figure. Now we know that all the value of minor losses or major losses, means the friction losses and the minor losses like a inlet loss, is defined by the 0.5 V1 square upon 2G. Okay, HF1 is a friction loss. We know that the head loss due to the friction is defined by the or find by the Darcy formula. So it is the 4FLV square upon 2GD. Here the friction is for the pipe 1. So here the F1, L1 and V1 and D1 corresponding for the pipe 1. HC, head loss due to the contraction. We know that how to get the contraction. Head loss due to the contraction is a 0.5 V square upon 2G. Now HF2 is a friction, again the friction loss for a pipe 2. So Darcy formula for FLV square upon 2GD. F, L, V and D is a for the pipe 2. Okay. Now HE is a head loss due to the enlargement. The sudden enlargement head loss is defined by the V2 minus V3 or bracket square upon 2G. Okay. Now again the friction loss for a pipe 3 is find out by the 4FLV square upon 2GD, and FLV D value is corresponding to the pipe 3. Okay. Now again write the equation. The total head difference between the free surface of water level of 2 tank equal to total head losses. Okay. Now put the value of all the values of all equations or all the values of head losses as shown in slide. Now if we neglecting the minor losses, then remaining is the friction losses in right side. Okay. Now if we consider the surface are same in a pipe, then the friction is similar in the whole section of pipe or all pipe. F1 is equal to F2 is equal to F3. So all friction coefficient is same, so it's defined by the F. So now equation become this, and now we common the friction coefficient for and 2G. So H, capital H is equal to 4F upon 2G in bracket L1 V1 square upon D1, L2 V2 square upon D2 and L3 V3 square upon D3. Okay. So this is the equation we find out for the total head loss, or we can say that the total head difference between the free surface level of water between the 2 tank as shown in figure. Okay. We see in earlier in figure. Okay. Now the equivalent pipe. Okay. Discuss about the equivalent pipe. What is the equivalent pipe? It is defined as the pipe of uniform diameter having the loss of head and discharge is equal to the loss of head and discharge of compound or series pipe. Okay, in short we can say that the pipe having a similar discharge and head loss which having a when the pipe in series. In earlier example we can take the 3 pipes where it is connected into the series. Consider the one pipe which having a similar discharge and head loss of this compound pipe, then the pipe is called the equivalent pipe. Okay. The uniform diameter of equivalent pipe is known as the diameter of series or compound pipe. Equivalent diameter of series or compound pipe. Okay. Now the relation is developed for equivalent pipe. So First, consider the same example which can take in earlier for a series of pipe. Okay, so 3 pipe in series. The length of all 3 pipe is L1, L2, L3. Diameter of this 3 pipe is a D1, D2 and D3. H is a total head loss. Capital H is a total head loss. Capital L is a length of equivalent pipe. D is the diameter of equivalent pipe. Okay. Now neglecting the minor losses, the total head capital H is equal to only the friction is there. So friction losses for all 3 pipe is a HF1 plus HF2 plus HF3. Okay. So friction losses is defined by the Darcy formula for FLV square upon 2GD. So for a friction coefficient L, length of pipe, velocity and diameter of pipe, value put in corresponding value of pipes. Okay, according to shown in slide. Now from the continuity equation we know that the discharge is constant for all 3 pipes. So discharge is equal to A1 V1 is equal to A2 V2 is equal to A3 V3. Now put the value of area for all 3 pipes, then we know that the cross section area, circular cross section area is a pi by 4 d square. Okay. Now get the value of V1 from this discharge relations. So the V1 is equal to 4Q upon pi d1 square. Okay. Similarly, V2 is equal to 4Q pi d2 square. Similarly, V3 is equal to 4Q pi d3 square. Okay. Now this value of velocity V1, V2 and V3 for the all 3 pipes input into the this equation. Okay. So finally simplify the equation or arrange the value as per the shown in equation in a slide and get this final equation for the total head loss when the 3 pipes are connected in series. Okay, or we can say that the compound pipes total head loss. Now the head loss in equivalent pipe is equal to capital H and the minor loss is neglected. So also here the minor loss is also neglected for the equivalent pipe. So only consider the friction losses for equivalent pipe is a defined by the Darcy formula is a 4FLV square upon 2GD. Now according to continuity equation we find out the value of V. So V is equal to Q upon A because Q is equal to AV. So V is equal to Q upon A. Okay. Now put the value of area pi by 4 d square because the cross section area is circular. So finally V is equal to 4Q upon pi d square. Now put the value of velocity in this equation of total head loss and finally we get this equation for the total head loss. Now we have a 2 equation of total head loss. First equation of total head loss for equivalent pipe and the other equation of total head loss for the compound pipe when the 3 pipes are connected in series. Now comparing the value of total head loss of both equation as shown in slide, then finally we get the equation of this type of equation. L upon d phi square is equal to L1 upon d1 phi square plus L2 upon d2 phi square d2 raised to 5 L1 upon d1 raised to 5 plus L2 upon d2 raised to 5 plus L3 upon d3 raised to 5. Okay. This equation is defined as the Dupuit's equation. From this equation, if the length of equivalent pipe is equal to the length of compound pipe, then the diameter of equivalent pipe is determined by this equation. Okay. I hope you very well understand the compound pipe, how to get the discharge in the compound pipe, and the relation we develop for the equivalent pipe and compound means the series pipe. Okay. Now the other one is a pipe in parallel. The pipe are said to be in parallel when the main line divides into two or more parallel pipes, when again joined together and continues as a main line. In short, we can say that the main pipe is divided into the two or three or more parallel pipe and some interval of length. Then further it's connected in one pipe and make the one continuous pipelines, single continuous one pipeline. Then it's called the parallel pipes. Okay. In this condition of parallel pipe, the total discharge or discharge in the main line is equal to the sum of the discharge of the parallel pipes. Okay. Means the mathematically Q is equal to Q1 plus Q2 as shown in the case considered in this figure. As per the figure or as per the case, the main line is divided into the two parallel line. Okay. When the pipes are arranged in parallel, the loss of head in each pipe is equal to same. Okay. So loss of head in pipe 1 is equal to loss of head in pipe 2. Here the minor losses is also neglected because the minor losses is very low or very small, so it's neglected. So only friction head loss is considered for the both, and both friction loss is find out with the Darcy formula of the both pipe in parallel. And now the friction coefficient is same if the pipe material is same. So the defined by the F1 is F1 is equal to F2, then is cancel. For 4 is cancel. G and G cancel. Okay. Now finally we get the equation. Through this, if we have a value of length, then we find out the diameter of pipe, and if we have having the value of diameter, then we find out the length. Okay, through this relation. Okay, I hope you very well understand the concept of series pipe in series and pipe in parallel. Okay, thank you.